Formulas for finding angles and sides of oblique triangles, the law of sines. An oblique triangle is any triangle that is not a right triangle. An oblique triangle has either 3 acute angles, angles less than 90 degrees, or 2 acute angles and 1 obtuse angle, an angle over 90 degrees. There are 4 possible solutions for finding an unknown side or angle of an oblique triangle. 1 side and 2 angles known, 2 sides and the angle between them known, 2 sides and the angle opposite a known side, and all 3 sides are known. If you know any 3 parts of a triangle, you can find the missing 3 parts by using one of the 2 following laws. The first law that we're going to work with today is called the law of sines. Now the law of sines will work for any triangle, but we usually confine it to using it with oblique triangles. Right triangles have their own laws and rules that apply to them, and they're probably simpler to use with right triangles. We have drawn 2 oblique triangles up here for you. The first one is an acute oblique triangle. It's called an acute oblique triangle because it has 3 acute angles or angles less than 90 degrees. The second one is an obtuse oblique triangle because it has 1 big angle, 1 obtuse angle of more than 90 degrees, and 2 smaller acute angles. These laws will work for either one of these types of oblique triangles. The most important thing when using these laws is to make sure that you have labeled your triangles correctly. It doesn't matter how you label the vertices on the triangles. What's really important is how you label the sides. We have randomly labeled the vertices of the first triangle in a clockwise direction as A, B, and C. When you go to label the sides, what you want to do is locate an angle, such as angle A, and go across the triangle to the opposite side, where you will label the side with a lowercase a. Similarly, if you have angle B, you'll come across the triangle and label the side opposite that angle with a lowercase b. And finally, you'll locate angle C and come across the triangle, labeling the opposite side with a lowercase c. It works the same in the obtuse triangle, although we've chosen to label the vertices in a counterclockwise direction. We have angle A, angle B, and angle C. But even in this case, when we locate angle A, we will find side A directly across from the angle. When you find angle B, you'll find side B directly across from the angle. And finally, when you find angle C, you'll find side C directly across from the angle. If you remember this simple rule about labeling triangles, you'll find the law of sines and the law of cosines much easier to use. The first law that we're going to talk about is the law of sines. The law of sines is the first of the laws that will help you to solve oblique triangles, and is actually the easiest one to use. You need only to remember a simple proportion. Remember how we labeled the side and the angle as being opposite each other? Well, that's because that side and that angle have a unique ratio. If you take the ratio of a side to the sine of the angle opposite that side, in other words, the ratio of A to the sine of the angle opposite A, you will find that that ratio is consistent throughout the angle and side pairs in the entire triangle. If I find side B and angle B, it's also true that the ratio B over sine of B will be equal to the ratio of A over sine of A. And of course, it follows that the ratio of the angle C and its side would be the same as well. So I can put side C over the sine of C. Now I have a proportion that's pretty simple to remember. I've got A over sine A, B over sine B, and C over sine C, and they're all equal. You can combine any pair of these and use your algebra skills to solve for a missing part. For example, I can say A over sine A is equal to B over sine B, and use that part of the proportion to solve a problem. Or I can use A over sine A equals C over sine C, and perhaps that would be the useful proportion. Or finally, I could do B over sine B equals C over sine C. Any combination of 2 of these ratios will be equal, and you can use them in solving problems. Let's look at an example. For our first example, we have a triangle, an oblique triangle, that has 2 angles of 48 and 60 degrees and 1 side of 23 inches known. We'd like to find the missing 2 sides and the missing angle so that we know all 6 parts of this triangle. Probably the easiest thing to do is to label this triangle before we ever get started. So we've labeled the triangle as angle A, angle B, and angle C, and we were careful to label the sides across from the angles correctly. I have side A across from angle A, and that's our known side of 23. I have side B across from angle B, and I have side C across from angle C. So I've labeled this triangle and I need to get started. The first thing I want to do is find angle C. Since I already know two angles of the triangle, that will be easy to do. I know that the three angles of a triangle need to add up to 180 degrees. So I know that I have to take A plus B plus C, and it will have to total 180 degrees. I know two of the angles. I know A and B. I know A is 48 and B is 62, and C is the missing angle that I'm trying to find. If I add these two together, I have 110 plus C is equal to 180, and using my best equation skills, I'll subtract 110 from both sides, and I find that angle C is equal to 70 degrees. That's going to help me to find all of the missing sides of this triangle. Now, in order to find the missing sides, I want to use the law of sines, which I've got written right here. Well, remember, it's just the proportion of A over sine A equals B over sine B equals C over sine C. I already know side A, so I can set up a proportion that I know both parts. I know the side and I know the angle. So the ratio that I want to set up is that 23 over sine of its opposite angle, 48, will be equal to the other combinations. If I'm trying to find side B first, I'm going to say, well, B is the missing number. That's the thing I'm trying to find. But I know that I can put it over the sine of 62 and keep this as a true proportion. Now, if I'm solving this equation, I want to have B stand alone in this equation. I want that B to be all by itself. Since it's divided by sine 62, I'm going to multiply by the sine of 62 on both sides of the equation. On the right-hand side of the equation, the signs cancel out, and I'm left with only B, which is the side that I want to find. On the left-hand side of the equation, I can simply do this on my calculator. I've got the sine of 62 times 23 over the sine of 48. Okay, we'll come to the calculator, and the first thing we want to do is take the sine of 62, so we'll say 62 sine. We'll multiply it by 23, so times 23, divided by the sine of 48, so we'll say 48 sine, and we'll be sure to hit the equal button at the end, and we get 27.3268. And so that helps us to find one of our missing sides. It helps us to find B. Now we know that any pair of these ratios would be the same, and I still have one more side to find. I still have to find C. I can use the combination of A over sine A equals C over sine C, and I know that that will be a true proportion. So I'll use the very same ratio that I started with here. I'll say 23 over sine 48 is equal to C, and if I look at C, I find that the angle opposite from C was the one we found to be 70 degrees. We found angle C to be 70 degrees. So we'll say C over sine of 70. Now when I'm solving this equation, I'm going to want to use the same technique that I did before. This is a very simple process. You're just going to repeat this technique, and I'll multiply by sine 70 on both sides. And these will cancel out. On the right-hand side of the equation, I'm only left with a C, and I need to go to the calculator to solve the left-hand side of the equation. So crossing to the calculator, I'll clear it out, and I'll start with sine of 70. So I'll put in 70 sine. I'll multiply it by 23 times 23, and I'll divide it by the sine of 48. Divided by 48 sine. And I'll be sure to hit equals at the end, and I get 29.0831. Now, at the beginning of our problem, we knew two angles and a side of the triangle. We labeled the triangle carefully. We found the missing angle to be 70 degrees, and then by two applications of the law of sines, just solving a proportion, we found side B to be 27.3268 inches long, and we found side C to be 29.0831 inches long. It's a pretty easy process once you remember the proportion. In any problem, it's good to check your work, and we'd like to check and make sure that the law of sines really worked in this case. The example that we knew The ratio that we knew was 23 over the sine of 48. That represented A over the sine of angle A. So let's see what would happen if we actually divided that out. We would have 23 divided by the sine of 48, and we get 30.949, or about 30.950, somewhere in that vicinity. So we'll take 30.9495. Now that's the ratio that we know everything else should equal. When we found B, we found it to be 27.3268, and we know that B was over the sine of 62. So let's check and see if that one comes out the same way. They should be exactly the same. So I'll take 27.3268 and divide it by the sine of 62. And sure enough, it comes out to be 30.9495. And finally, in C, we had C over the sine of 70, and we found C to be 29.0831. So we'll put in 29.0831 and divide it by the sine of 70 degrees. 70 sine. And it equals 30.9495. So all of those ratios have exactly the same numerical value, and we know that the law of sines worked and gave us the correct lengths of the sides of the two missing sides in the triangle.
If you understand the law of sines, you can isolate any side or any angle. Let's just take two of them. A divided by sine A equals B divided by sine B. And remember to use small letters for the sides and capital letters for the angles. Now, by means of cross multiplication and our algebra skills that we've learned by now, we can cross multiply. So this equals A times sine B, that's this over here, equals B times sine A. B times sine A. Now we can isolate the A, the sine B, the B, or the sine A. All we have to do is divide. And I say we want the A isolated. We divide each side by sine B. And so A equals then B times sine A divided by sine B. And you could do that with any one of these. We could do the B and the C together. So let's take the B over sine B equals, and make a small c over sine capital C. And let's just cross multiply. And B sine large C equals C times sine B. Now let's say we want to isolate the sine C. All we have to do then is divide each side by B. And so sine C would equals, it will be C sine B divided by B. And as you can see, by using the law of sines, you can use that very conveniently to find the sides and the angles of oblique triangles. Let's take a look at this problem. A ship is traveling east and it spots a light in the distance. It takes the reading from north and it's 59 degrees 20 minutes to that light. It travels another 750 feet and takes another reading from north. And now it measures 44 degrees 35 minutes to the light. How close will the ship get to that light? What is the closest that ship maintains its course traveling east will it ever get to that light? And with the laws of sines and trigonometry, we can find this distance. Let's start to solve the problem. Let's label this angle as A is the angle that we want to find out over here. And this will be small a. And we want to find in this right triangle, this is a right triangle, that makes it the shortest distance. And what we want to find is this side B. We'll make this B, and so this will be angle B. And if we get this side here and a known angle over here, then we can find this distance here. So let's try to find the side B of this triangle. Now this is 59 degrees 20 minutes, and this is 90 degrees, then we know what this angle is. So all we have to do is deduct 90 degrees, or 89 degrees, 60 minutes, and deduct 59 degrees, 20 minutes, and we have 40 minutes here, and this will be 90, and this will be 30 degrees. So angle B here equals 30 degrees, 40 minutes. We know this angle from here is 90, and all we have to do now is add 90 to 44 degrees 35 minutes, then we have this angle. And so 90 degrees plus 44 degrees 35 minutes equals 35 minutes, and that would be 4. So this angle, all inclusive in here, this will be angle C. That'll be 134 degrees 35 minutes. Now we have angle B, we have angle C, and if we know two angles of any triangle, we always know the other angle, because all the angles of a triangle always equal 180 degrees. So we can start with 180 degrees, and all we have to do now is deduct 30 degrees 40 minutes and 134 35 minutes from 180 degrees. So let's put these two together. 134 degrees 35 minutes plus 30 degrees 40 minutes. That'd be 75 minutes, and this will be 164 degrees. Now we have to deduct 60 from here, bring it down, minutes, and we'll add 1 onto here. So that will equal 165 degrees and 15 minutes. Now we deduct that from 180, and we know we have to convert this into 179 degrees, 60 minutes, and deduct 165 degrees, 15 minutes. This will be 45 minutes. This will be 14 degrees. And that will be angle A. So angle A over here equals 14 degrees, 45 minutes. Now what we have here, we have angle A and we have the side A, and we also have now two known angles. We know angle B and we know angle C. What we want to know is side B. So let's use the law of sines. A over sine A equals B over sine B equals C over sine C. Now we definitely want to use the angle A and side A. That's one of these we want to use. Now we want to find which one do we want to use here, the B over sine B or the C, side C over sine C of the angle C. We want to find B. and we know angle B is 30 degrees 40 minutes, so we want to use this. So these are the two formulas we're going to use. So let me erase this over here so I have more room to write. So A over sine A equals B over sine B. Let's cross multiply. So A times sine B equals B times sine A. Now we want to isolate the B, so we divide each side by sine A this cancels out. So now we have the formula B equals A times sine B divided by sine A. Now all we have to do is plug in our numbers. A we have over here is 750 feet. So 750 times sine of B, which is 30 degrees 40 minutes, sine 30 degrees 40 minutes divided by sine A, which is 14 degrees 45 minutes. 14 degrees 45 minutes equals B. Now let's go to the calculator, plug in the numbers, clear the calculator. So 750 times sine of 30 degrees point 40 minutes, which is 0.4, decimal sine divided by 14 degrees point 45 minutes, decimal sine equals, so B equals 1502.47 feet. So B equals 1502.47 feet. Now we have here a right triangle. And so we know now the hypotenuse of this right triangle. So let me erase this so I have some room. We don't need the law of sines anymore now. Let's just put up that old Indian name, Toa. Now we need to know another angle over here. Now we can find this angle over here. Now we know this is 180 degrees, and we know this is 134 degrees 35 minutes. And we also know that this angle from here to here is 44 degrees 35 minutes. Now we could take 180 degrees and deduct 134 degrees 35 minutes, or we could use 90 degrees and deduct 44 degrees 35 minutes. So we'll use 90 degrees, so that would be 89 degrees and 60 minutes. And we have to deduct the 44 degrees and 35 minutes. And so this will be 25 minutes. And this will be 5, and this will be 4. So this angle is 45 degrees 25 minutes. So what do we have here? We know this angle, and we know the hypotenuse. So with SOHCAHTOA, we know it's going to be either sine equals opposite divided by hypotenuse, or cosine adjacent divided by hypotenuse. Either one of these two. Because you know the hypotenuse, so we're not going to be using the tangent. Now we want to find the opposite side, which is x over here. And the only one that has it is the sine, the SOA, so we're not going to use this one either. So sine of 45 degrees 25 minutes equals The opposite, which is the unknown, is the x, divided by the hypotenuse, which is 1502.47. Now we want to isolate the x. So x equals sine 45 degrees 25 minutes multiplied by 1502.47, and that will give us this unknown side. Let's go to the calculator. Let's clear it. Sine of 45.25, make that into decimal, and sine times 1502.47 equals, and x equals 1070.1 feet. So that ship traveling east and takes a reading when it sees that light and gets a reading of 59 degrees 20 minutes and travels 750 feet and takes another reading at 44 degrees 35 minutes, the closest it will ever go, if it keeps a straight line traveling east, will be 1070.1 feet. And as you can see by using the law of sines and with the trigonometry formulas that you've learned in this course so far, you can solve very complicated problems. I want to show you various scenes from our space program. As you look at these scenes, think of all the math and science used to build this equipment and the computers to operate these devices. As you look at these scenes, think of the math that was needed to design and build this complicated equipment and place them into orbit. Enjoy these scenes and marvel at technology. Remember, everything had to be designed and built. Think of the importance of math and science in producing these amazing accomplishments.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.